I'm going to talk specifically about the CHIRON project, which was just finished this last year and funded by Innovate UK, which is about a physically assistive robot. But just looking at the talks and the audience here, I've got some preliminary slides just talking about some of the other commercially available robotics technology around sociobots and support. This is the real life robots. Okay, now there are some features on this picture that I just wondered if you can notice. So what do you notice about this picture of robots in a factory? Sorry, shout up. Sorry? No people, that's great. And that's because most robots, most physically assistive robots, are not safe to use with people. So you don't want people anywhere near the robots at all because they might get hurt. Okay. There are also lots of robots there as well. And there's another little feature about them which I'll give you the answer for. They're also not humanoid. Okay. So there's no reason for a robot to look like anything like a person. You just need to design it to do the function that you want it to do. Okay. So let's think about sociobots first. So these are robots that aren't necessarily physically assistive. There's the Castle one there, which is sort of like a mobile information thing that can follow you around. There's the Honda Asimo that can talk to you and hold a sort of a conversation. These are being used for children with autism very effectively. And somebody mentioned the Pepper robot here, which is probably probably one of the most advanced commercial platforms that we've got available at the moment. Pepper is actually very clever, so it's got emotional recognition, so it can tell if you're looking at it, it can tell from the speech, the intonation of the speech, whether you're engaged with it or not. It's got the touch screen on the front, it's got quite a lot of sensors, so it's sensitive on the head and on the hands, and it's also got robotics words, self-localization and mapping. So in other words, Pepper could find its way around this sort of audience here. So it's really a pretty clever piece of £30,000 worth of kit. Inspired by some of Designability's work on electronic prompting, where we're using touchscreen tablets to guide people with early cognitive impairment through multi-step activities. Our collaborators and colleagues, in particular Praminda Caleb Solly over at the Bristol Robotics Laboratory, programmed Pepper to provide support around a cooking activity.
Praminda, is it time for you to have dinner?
Yes.
Should I help you?
Yes.
Okay, Lucy left you some macaroni cheese. Would you like to have that?
Mm-hmm.
Have you got it?
Yes.
Next, put it in the microwave. Make sure you have removed the cardboard sleeve. Tell me when you've done that.
Okay, done.
You need to set the timer for 3 minutes. Use the dial on the bottom right of the microwave. It looks like this. Can you see it?
Yes.
Watch the numbers on the screen increase. Stop when you hit 3 minutes. Does it say 3 minutes?
Yes.
Great. Now you can press start. Tell me when you've done that.
Okay, done.
Now, we wait. I think it's ready. Time to take it out. Be careful though, remember the plate will be hot.
So Innovate UK funded the CHIRON project 2 or 3 years ago, and the aim of the project was the focus was to support people living at home independently in their later years. So that's what is on the radar at the Department of Health and within social care, because of the vast numbers of people that we're going to have over the age of 80, 85 and 90, and the lack of carers. So the aim was to develop a robotic system that would operate within an intelligent ecosystem, and basically that means within your home Wi-Fi or whatever. Could be integrated with other consumer products like Alexa or Google Home, And we wanted it to be a modular robotic system so that it could have multi-functions. And the aim of the 2-year project was to develop a working proof of concept. So really quite a big challenge within 2 years. So we did quite a lot of work around with focus groups around looking at unmet needs, around the sorts of tasks that people might need help with in their home in their later years. And the sort of things you can see there are fetching and carrying things. So if you've got Parkinson's, for example, you've got a very significant tremor, how are you going to get some hot food out of the oven onto your plate and then over to the table? And clearly, transfers and mobility were other very big issues. So just getting in and out of a chair, being able to move around the room and going to the toilet. So what we wanted to do was to effectively focus on 2 key tasks for this demonstrator system, and those were fetching and carrying, and then assistance with getting out of a chair and walking around. So this is some of the visualization that we used with the focus groups. So you can either have the track built in or freestanding. People wanted a tablet interface as well as a voice interface. They wanted a range of attachments. So these are just some of the visualizations. We were tremendously fortunate this was a project in partnership with the Bristol Robotics laboratory and also Shadow Robotics, who are based over in London. And we were very fortunate to have the use of the Assisted Living Studio over at BRL, and this is effectively it's a fully contained flat, but it's like a film set flat, so you can't actually use the toilet or you get into big trouble. So these are the visuals. So we've got the rather than a passive track, we've got a driven XY track on the ceiling. And then we've got an arm that comes down, that's the Z-axis, which is the vertical axis, with some sort of gripper attachment. And we had the idea of having a tray, we called it a smart crate because it's technology, but basically a fancy tray that you could put things on that the gripper would be able to attach. And the vision is that the user would be able to load up the tray perhaps in the kitchen, and the CHIRON system would be able to follow the user through into the living room and bring the hot drink to them. That was the vision there. The safety and control are really very key parts of the system, and a lot of work was done around that. So what you've got on the left is the picture of the CHIRON system there, and we've got 4 Connect cameras which measure depth as well as picture, and they're feeding information into the robot's brain, into the CHIRON's brain, to build up a picture of the room, of the obstacles around the room. So you can see that there. It's all rather blocky, but the bit here is the table. Can you see that there? Yeah. Yeah, and then the basket there and the doorway. It doesn't need to be too accurate because there is a camera on the end of the Z-axis there. So the cameras are building up a picture of what's in the room so that when you want to identify an object or maneuver around an object, then the robot can do that safely. This is a picture of the end effector. It looks rather chunky. It's got a very novel compliant tube that lifts it up and down from the ceiling, so it can go from very close to the ceiling right down to floor level. And because it wasn't very stable, for the proof of concept, we put this tube structure around it. But what you can see at the bottom here is a rotating joint, like the wrist, and then this is the gripper here. Yeah, we haven't put the arm on this particular demo. So I'm going to show you a little video clip of it working. It is quite slow because the computer's really working very hard, and this was an early prototype. The system will move very quickly, but obviously for safety's sake, you don't want quite a large mass moving very quickly across the kitchen if you're not sure whether it's going to stop accurately or not. So just bear with me on the speed here. The gripper's got a dual function, so the jaws will pick things up, but the middle bit will is designed to pick up the tray. Now the large cardboard box that's just coming into view was a surrogate for an object, a person in the way of the arm, okay? We didn't quite trust it to put a real person in there at the time. So using the vision system, the computers pick the box up and it's navigating around the side of the box. To get to the chosen location. So nice smooth movements, hopefully no coffee has been spilt in the exercise. So the other challenge we talked about was helping with sit-to-stand and moving around the home. And this is the current state of the art for your sit-to-stand assist. So the vision was to have we're using the Google Home voice interface. So would you like some help? The CHIRON system would come over. It would have changed the end effector from the pick and place to the sit-to-stand end effector. This was the first visual sort of impression. Most of you will or be aware that there are a whole little sequence of activities around a sit-to-stand that you do need to coordinate in order to stand up successfully and stay stood up. So it was really important that the robot had knowledge of this and is able to monitor this with the video cameras so that the manoeuvre is safe. This is the end effector that we actually designed for the prototype. So we wanted it to be very adjustable, so we used that steel frame, but you can see the modular connector onto the Z-axis there, and there's force control in the two in the two handles, so the system knows that if you're putting load onto it, and you can also use the force on the handles to adjust the position.
Help me to stand.
Okay, where are you at the moment?
Hey Google, I'm on the bed.
Okay, I'm sending CHIRON to you now. Be careful as it moves. You can adjust the hand grips so they're in a comfortable position.
Hey Google, I want to adjust the position.
Okay, move the handles.
Hey Google, I want to adjust the position.
Okay, move the handles.
Hey Google, I'm in a comfortable position.
Okay, let me know when you're ready to stand and I'll count you down.
Hey Google, I'm ready to stand.
Okay, ready, steady, stand.
So that's as far as we got, which the project finished in March just this year. So effectively we've got the little green CHIRON project up the top there. So we have a proof of concept demonstrator. So what we're now looking for is, to be frank, several £1 million to develop the various other aspects around the functionality, around the sensing and the vision and the control, and making it look rather better than it is at the moment. So there's quite a lot more work to do, but nevertheless we have been able to prove proof of concept. The engineering is all very doable, and so you can see that we would then go into the next phase around sort of testing and development. There are a significant number of regulatory requirements around any assistive technology, as you may well be aware, that we would need to meet. We would also need to meet the standards relating to the design and function of robotics, and there's also a personal care robot standard that's been written and is there, so we would need to make sure that all the safety requirements were that. And then as the CHIRON system is providing personal care and the user is interacting with it, we also need to think about personalising the care to make sure that dialogue relates to the person-centred care and is appropriate for the individual. So you can see there are quite a number of other barriers quite apart from the engineering challenges that we face. So just to summarise then, robots, that can provide physical assistance are at an early stage of development, as you've seen, and there's quite a lot of work needed on the sensing and the vision and the mechanical components and the artificial intelligence. But these problems will be overcome, as I've said, in the next 10 years or so. There's quite a significant amount of work needed to address the safety and regulatory issues that we need to be thinking about now. So robots are coming, and they will offer significant potential to support independence, health and well-being. And as I said, we need to consider the safety and regulatory issues. So the Skills for Care have produced a very nice report that just literally came out in the last few weeks around using AI and robotics for social care. So it's available to download. So as practitioners, you should be reading this, you should be thinking about what your practice might be, you should be thinking about the future workforce if you're commissioning, and you should also your voice should be heard. You should have that dialogue with the engineers and the system developers to make sure that you are, as well as your clients and the people you look after, but as care professionals, that your views are considered and input into the development of this technology. Thank you.